On Friday, guys, we started talking about this other thing called the activity series. What type of reactions, who can tell me, what type of reaction do we use the activity series for? Not synthesis, single replacement, guys. So we use it for a single replacement reaction. Okay. What is it, though? What is the activity series? Exactly. It's that table, guys, that shows us the ability of materials, of different substances, different elements, their ability to replace other elements in that reaction. Okay? So, it's used for single replacements. It looks like this right here. Alright? We've got an activity series for halogens, and we have an activity series for metals. Alright? Where are the more active metals or halogens located? Right, the top. So more active here at the top. If you have not already done so in your own personal reference packet, okay, I want you guys to write more active at the top of the series. So as you go up the series, it's more and more active, meaning the elements at the top of this chart will replace pretty much all the other elements, all right, that are below it. The higher up you go, they will replace the ones that are below it. Now, we also talked about how on Friday, those last three elements there at the bottom, silver, platinum, and gold, why it's a good thing that they're down at the bottom, because they don't react with oxygen. Where do we find those three elements a lot? Jewelry. Okay, and it's on your skin. What?
Nothing.
What?
Continue, sir.
The look you just gave me was like, huh. Anyway, guys, they don't react with your skin. If you've seen jewelry that kind of wears off, and it turns your skin a different color, it's not silver, platinum, or gold because it's oxidizing with the air. It's some other cheap material. All right, it's a knockoff, not real. So, here we go. You're going to practice, guys, on page 15. I believe that you have these reactions listed there in the middle part of page 15. You're going to identify, say, all right, will these actually work? I want you guys to go through whenever you find a reaction that won't work, meaning the element that's by itself in the single replacement reaction is lower on the table than the one it's trying to replace, you will write no reaction. If the element that's by itself is more active, it will go in and kick out the piece that is like it, and you have to predict the product. So let's do one together. Nickel and then copper 2 chloride. What element, guys, in that compound is nickel going to try to replace? Right, so if we split it, it's going to replace copper. Well, let's take a look. I have nickel. The hardest part is finding it on the list. It's what? There it is. Nickel is trying to replace copper. Will it work?
No.
Yes, it will, because nickel is more active, guys. It's higher up on the chart. So, nickel is going to come in and kick out copper. So, what's our new products going to be? This is reaction prediction right here. Now, part of this, it doesn't tell us, guys, what nickel is. So, and nickel has more than one charge. It's got multiple charges. So we're going to say it's nickel 2. All right, this is nickel 2. It says nickel. All right. So, nickel 2 chloride. What's our formula going to be for nickel 2 chloride? Right. Will chlorine always have that same subscript? No, guys. This is the only time where subscripts can change is when you're predicting products. You always have to go back and use what method? The crisscross method. All right, you got to use the crisscross method. And then what's our other product going to be? Copper. There it is, guys. I want you to go through and do these last four. If no reaction can occur, guys, all you have to write is no reaction because there will be no products. Take a few minutes and try it. Zinc will try to replace lead. Again, cations replace cations. Metals replace metals. There you go. So, over here, guys, will it work? There is zinc. Where's lead? Absolutely. So who can tell me what our products will be? Do we know the charge on zinc? 2. Yes, we do. It is a 2. So our products will be what? Oh, yeah. Wrong equation. This is what you should have for your products, guys. Let's take a look at the next one. Cl will replace what element?
K.
No.
I.
I, because chlorine, guys, is a halogen. It's an anion. It's going to replace I. Now, if you forget that, folks, take a look. Here's chlorine right up here. I, they're in the same one. You will not find chlorine down here to see if it replaces calcium. It's only at that top in the halogens. There's a hint as to which one it will replace. So, it will work because chlorine is higher than iodine. So, we're going to have, what's my formula going to be? KCl plus. Now, does it matter, guys, which order I write my products in? No, it doesn't matter because there's a plus sign. Whether you write iodine first or potassium chloride, that's fine. But what else? Are we done with this equation? No, we have to balance it. The other two took care of themselves. How do I balance this? There we go. That's how it's balanced. All right, the next one. Copper. Who is copper going to try to replace? Iron. Let's see if it'll happen. Here's iron. And copper, we've already said, is way down here at the bottom. Will this reaction take place? No. So we can just write no reaction. Because copper is not more active than iron. Iron is more active because it's higher up on our chart. For the reaction to take place, you have to have an element. The element that's by itself that's trying to do the replacing has to be higher on the activity series, meaning it has to be more active for the reaction to take place. Does that make sense? The one that's by itself has to be higher up on the series in order to kick out the other one. All right? And then the last one, barium. Who's barium trying to kick out? Hydrogen, right, guys? This is where drawing that line comes into play. Because the cation will always replace cation. Metals act like cations, where they are. So it comes in, it's going to try and kick out hydrogen. Let's see if it will actually work. I've got barium, it's the fourth most active. Hydrogen's way down here. Will this reaction take place? Absolutely. So we're going to get what? VAO. How did we get that? Again, Va2 plus, oxygen 2 minus, crisscross method plus. How do we write oxygen? Hydrogen, I mean. Why is it H2? Brinkelhoff. It's a diatomic. Folks, there's some practice with predicting products. Single replacement, that's how we do it. On your test tomorrow, you will only have to use the activity series if the directions tell you to. All right, I'll say it again. You only have to use the activity series if the directions tell you to. All right? All right, let's try and see, will these synthesis reactions occur? What do you think I'm getting at here, guys, for these synthesis reactions to occur? Okay, so they're all gases, but that doesn't mean that they will or won't occur. Here's the deal, guys, with oxygen as a reactant, this is where this part of the activity series comes into play. Reacts with oxygen to form oxides. So for those, if you see a question like that, dealing with oxygen, it has to be one of those elements up there that follow this arrow. Okay? For those reactions to occur, those synthesis reactions, they have to be in that section. So if we take a look, calcium, is that one of those that's in there? Yes. It is. So will that reaction occur? Yes. Absolutely. What's our product going to be in a synthesis? How many products will we have? One product, right? So what's our product going to be?
CaO2.
Is it going to be CaO2? CaO. Why is it CaO? Ca is a +2, oxygen is a 2 minus. When we crisscross those, we get Ca2O2, but we have to reduce. You have to go back and do the crisscross, guys. Do not assume they're going to have the same subscripts when you're predicting products. Is this reaction good? No. What else do we have to do? Balance it. We need a 2 in front of Ca, and we need a 2 right there. The next one, nickel plus oxygen. Will that take place? Absolutely, because nickel's right there. It's within that arrow. So again, this doesn't tell us what it is. Let's say it's just going to be nickel 1 in this case. We're going to say it's nickel 1. What's my formula going to be if that is nickel 1 over there on the left? Write your crisscross out. Nickel is a 1 plus. Oxygen's a 2 minus. What's our formula going to be? Ni2O. How do we balance that equation? 2, 1. Is it going to be 2, 1, 2? Yeah, it's 4, 1, 2 is what it would be. That's how you balance that. Do you have to write the ones in there? No. You do not have to. If you don't write anything in there, guys, I'm assuming it's a 1. Question? At the bottom. So gold will not react with this last one because it does not form an oxide with oxygen. So no reaction is all we have to write. Okay? Guys, any questions about the activity series? Don't make it harder than it needs to be. You will have questions on your test tomorrow, a whole section, where it'll say which is the most active. And all you got to do is either, I can't remember if you circle it or you write it in there. Don't make it harder than it needs to be. All right? All right, here's some review practice, kind of concept questions. These are the types of multiple choice questions that you could see on your test tomorrow. Now, these aren't multiple choice, but you get the idea. So, in this problem, guys, what is oxygen in this problem? How would we classify it if we're going to? Not a gas, because it doesn't say a state of matter there. It's a product, guys. Where is it in the reactant, or excuse me, in the reaction? It's a product. All right. What type of reaction is this? How do we know it's a decomposition reaction? One reactant. That's how we know for sure it's decomposition. What does the 2 in front of oxygen represent? Okay, not just 2 O2s, 2 what? What do coefficients represent? It's from our notes. Folks, oxygen, the 2 in front of oxygen represents the number of moles. That is what coefficients represent. That's why we can balance our equation, because we change the number of moles. We don't change their subscripts in a compound unless we're predicting. When we balance, we change the number of moles. The 4 in LiClO4 is a what? Is it a coefficient or it's a subscript? Okay. What do subscripts tell us? The number of what? The number of atoms. The number of atoms you have, guys. So, subscripts tell you the number of atoms. Coefficients tell you the number of moles. All right? So, be able to identify, guys, subscripts versus coefficients. All right? Subscripts versus coefficients. Let's do another question or two, folks. All right, another question. Which pair of substances would undergo a single replacement reaction? Give you guys a minute or so to figure that out. In order to answer this question, folks, what do we have to look at? The activity series, all right? So this is a multiple choice question. Which set will undergo a reaction? A will?
C will.
Will it? No, guys, lithium is the highest, most active, so nothing is going to replace lithium, all right? But if we take a look at the first one, iron is going to replace cadmium. Let's go back and take a look. Went too far. Iron is right here. Cadmium is just below it, so iron will replace cadmium. Okay. Platinum's not going to replace anything because it's at the bottom. Lithium's the highest, so nothing's going to replace that. Let's see if bismuth is higher than hydrogen. Here's bismuth down here. Hydrogen's right there. So only A will the reaction actually occur. Okay, again, the element, guys, that is by itself has got to be higher on the series than the one it's trying to replace. All right, here we go. This is a review question from back in like Unit 1 or Unit 2, folks. Since we're dealing with reactions, we've got to come back to it. What are the 5 possible signs that a chemical reaction has taken place? Give me one.
Temperature.
Temperature change. Hold on. Maybe you want to jot these down if you don't remember them. Mikey?
Is one of them light?
Light is sometimes. There's better ones than that. Catherine. Color change is one. Nope, because they're not physical changes. They're chemical changes. Lily. Smell, again, is sometimes. So we're going to leave that off to the side. Sam? Okay, so formation of a precipitate. I can't write today. Precipitate formation. Caroline? Right, so heat. That would be like a temperature change. What else, Catherine? Not gas to solid, but the other one could be just bubbles, right? Which means a gas forms. Exactly, guys. That is a chemical change, is that a thing makes a new thing. That's basically what's going on. So that's why it's different than a physical change. But these are the four, guys. Temperature change, color change, formation. What? These are the four best answer choices. Odor is sometimes, and that's that fifth one in there, guys. It's only sometimes. But why I don't like to put odor in there, I need to change that from 5 to 4. Know these four for sure. All right? These are the four best. But odor, guys, because sometimes substances will have an odor to begin with. So when you react, it's kind of a false positive, thinking that, oh, there was a reaction that actually occurred when something by itself had that same smell. Does that make sense? Okay. So those are the four best answer choices. Odor is sometimes and light is sometimes. But again, not the best. Those are the four best for sure. All right, what does a formula equation mean, guys? So there's two types. We have a formula equation and a word equation. What does a formula equation mean? Exactly. This is all the symbols, folks. Like the chemical formulas. Again, that seems obvious, but when you're reading questions or you're reading directions, guys, a lot of times people will forget that. A word equation has all the words. You have to write the formula equation out where you have the chemical formulas. All right. What do you adjust in an equation to balance it? Coefficients. You do not change subscripts when balancing. All right, do not change your subscripts when you balance. All right, these symbols, you've got to know all your symbols for your test tomorrow. So we have solid, liquid, gas, aqueous solution.
Yeah, that one's up and down.
It's not up and down.
Oh, wow. That's solid.
On liquids, I just put up and down.
I said decrease.
Formed, guys. That's the key. Where will you only see these two? They will only be in what part?
Water.
Products, guys. These will only be on the product side. All right? The arrows will only be on the product side. Mikey.
Is it because gas is